We have always thought that our memories are extremely reliable. However, memories are more dynamic than we think. Science has proven that they too can be manipulated. Memory was once considered to be a library in which we consolidated our most treasured moments. It was believed that once stuck in the brain, the memory stayed unchanged forever, even upon recollection. When you experience something such as eating the most delicious burger of your life, the brain's memory process activates. The experience is translated into a pulse of electrical energy that propagates along a network of neurons. When we have an experience of strong emotional meaning, we have a high chance of retaining it as a memory. Memories are a set of firing patterns between neurons and synapses. This pulse will first land in short-term memory, however, this will only last seconds to minutes. It is then transferred to the hippocampus to then be converted into a long-term memory stored in the cortex. Every time Diana eats a burger, the same neurons are fired, allowing the formation of long-term memory which is stored in the appropriate cortexes. Memory consolidation occurs when RNA synthesizes new proteins to strengthen the synapse. Now that the memory is being recalled, the brain is retrieving information from the same set of neurons being fired, establishing the final stage of how we remember. In 2000, through memory manipulation, Karim Nader revolutionized how we think of memory. He trained rats into fearing a tone by pairing it with a mild foot shock. The rats then acquired a long-term memory associated with the tone. The memory was recalled when the tone played and the rat froze due to fear association. The rats were then administered anisomycin, a drug which blocks the proteins which build the connections to form a memory. In theory, the drug should have no effect. However, this experiment showed when the tone was played again, the rat was no longer scared after administered the drug. The drug not only blocks the formation of the memory, but also blocks memory recollection, which demonstrates that our memories are susceptible to change and synapse surgery is possible. Nadar's experiment then influenced a 2016 study involving arachnophobes, which demonstrated a form of memory manipulation associated with arachnophobia through the administration of drugs as a form of synapse surgery. In this study, the patient was asked to touch a spider. This initially spiked a fear within the patient, resurfacing the original memory associated with the fear of spiders. The patients were then instructed to consume propranolol, a blood pressure medication that blocks the release of noradrenaline in the amygdala, the fear center of the brain. This interference then blocked the reinitializing of the original fear memory. This makes the phobia more unstable by disrupting the reconsolidation of the initial fear associated with that memory. The therapy worked in 100% of all cases. Scientists have also been able to implant memories by manipulating original ones through psychology and optogenics. Another study demonstrated psychologists implanting false memories into participants in a study by telling them that they did something when they didn't. So what could have happened turns into what would have happened, then turns into what actually happened. Optogenics allows us to map specific memory, but also turns the memory off and on by manipulation through lasers. Using genetically modified mice, it allowed the scientists to turn off and on specific memories at any time. They started by putting the mice in a new environment, creating fear. However, the goal was to override this fear with a happy memory. They achieved this by recording the exact neurons that fired in an environment that created a positive memory for the mouse. They recorded this by genetically modifying the mice so that they could permanently label an individual memory by stimulating a protein similarly found in algae that responds to light. Therefore, when the drug was injected before the positive experience that turned the light gene on, it triggered any brain cells that fire within the hour to install this light-sensitive protein on their surfaces, thus leaving a neuronal footprint in the brain of the mouse. When the drug wears off, only those cells will be stimulated by light. When the mouse is in a fearful environment and the fiber optic lasers are turned on, the same neurons from the positive memory are activated, effectively causing it to relive that positive experience, which is evident through the mouse exhibiting happy behavioral traits. When the laser is turned off, it resumes being in a fearful state. Neuroscientists have excelled in understanding memory through advances in research and technology, leading to discoveries about memory manipulation, implanting, and synaptic surgeries. However, there is still so much more to discover. Such discoveries bring forth ethical challenges such as allocating benefits to be equitable, ensuring risk is alleviated in research, and that the distribution of these discoveries benefits society. What society once thought was science fiction is now becoming a reality. Neuroscientists have envisioned a future where patients with severe memory loss from disorders such as dementia or amnesia and post-traumatic stress disorder can be treated through synaptic surgery.